In this example, we're going to be looking for a missing dimension of a shaded section, and we're also going to be looking to try and find the area of that shaded section. However, we are not given actual numbers for our dimensions. So we're given an unknown here, and you'll notice that I have two drawings. And in one of the drawings, I'm going to treat one of the drawings as if it was just using numbers to try and find it first. This is going to help me understand how I'm going to find that missing dimension. So instead of this being h meters, I'm going to change this to 10 meters here. And this will be our numerical way of doing things here. If I'm trying to find this missing dimension here, however many meters this little part is, I need to figure out what I would do to get to that. So what we know is that this whole length of this square is 15. This part up to here is 10 meters. We need to figure out what that little spot is there, what the rest would be. So if the whole thing was 15 and that part was 10, to find the remaining part we would use subtraction. So we would do 15 minus 10 equals 5. And that means that this part right here, that's 5 meters. Now to find the area of that shaded section, I know that one part is 5 meters, and then I know that this length is 15 meters because it is the same length as this bottom length down here. And then to find area of a rectangular shape, it is length times width, so the area would be 15 times 5. 15 times 5, 5 times 10 is 50, 5 times 5 is 25, so that would be 75. And it was meters times meters, so that is meters squared. Now let's look at it algebraically. So on the algebraic side here, it's not 10 meters, it's h meters. When we were doing it with numbers, we had 15 minus 10, so we took this length, this full length, and subtracted this piece to find the remaining piece. So we're going to do the same thing here. So to find out what this side length is, now it's just going to be 15 minus h, and that is in the form of meters. We cannot do anything else here because they're unlike terms. So this measurement here, the length of the side is 15 minus h meters. To find the area, we follow the same steps here. It's length times width. So our length, again, is 15 for our length. So for our area here, we have 15. And then we need to multiply it by our width, which is 15 minus h. So I'm going to bring down that difference of 15 and h. And we're going to multiply 15 by both parts. We could do that using the distributive property. So we have 15 minus 15. 10 minus 15 is 150. Then 5 minus 15 is 75. So 150 and 75 would give us 225 for that first part. Minus 15 times h is 15h. And this, again, would be in the form of meters squared. So a good method to use when you're trying to find missing dimensions or area of shapes, of geometric shapes that you don't have all of the numbers for. So when you're given variables, is kind of just scribble out that variable, put in a number, try and do it with a number, and then follow everything else. So what we did here was we replaced this 10 with that h the first time around, and then we replaced the length of 5 with the length that we found of 15 minus h.